Hey guys, so I'm going to explain two theorems to you guys today about similar triangles. So let's get right to it. There's the triangle mid-segment theorem and there's the triangle proportionality theorem. Now what the mid-segment theorem is saying, it's kind of like a definition. It's saying a mid-segment of a triangle is parallel to the side of a triangle and its length is half the length of that side. So if we truly call this a mid-segment, for example, all right, if we call PQ in this image a mid-segment, then we're saying two things. We are saying it is parallel to LN, and also it is half the measure of LN. All right, one thing to notice is that the triangle MPQ and the larger triangle, excuse me, sorry for my sloppy drawing. All right, the larger triangle MLN are similar. All right, their angles are all the same. You might remember, for example, corresponding angles being congruent. But that's a little bit extra. Anyway, we're saying this triangle is going to be half the size of the larger triangle. So that's the triangle mid-segment theorem. And we can solve problems with it. For example, if we say that PQ has a measure of 38 minus 4x, so we're going to give it an expression, and we know also LN has a measure of 58 minus 5x, then we can set up the our mid-segment theorem by saying, okay, well, if I take twice of PQ, I will get the length of LN, right? In other words, twice of 38 minus 4x should be the same as 58 minus 5x. And I'm going to pause and solve. All right, and so when I set up my equation saying 2 times 38 minus 4x is equal to 58 minus 5x, and I use my algebraic steps, I reach the conclusion that x must be equal to 6. So if I were asked the question, well, what's the measure of LN? I could just substitute this value 6 into x. Or if I was asked, well, what's the measure of segment PQ? Again, I could substitute 6 in for x to find those side measures. That's the mid-segment theorem. Okay. Now, there's also something to be said about the triangle proportionality theorem. So the triangle proportionality theorem states if a line is parallel to the side of a triangle, kind of like PQ and LN, right? Then it divides those sides proportionally. So if we looked at the side lengths of all of these, then it's going to divide it proportionally. And that makes sense because I just told you the two triangles, MPQ and MLN, are going to be similar. So let's look at an example of the triangle proportionality theorem. Delta Math calls it the side splitter theorem. All right, but to use correct vocabulary, let's call it proportionality. All right, so again, if I think of similar triangles, this becomes a piece of cake. All right, I can think of it in several ways. All right, so one way is we can make a proportion. So we can say 6 is to 21 as 2 is to x. All right, similar relationship. We can cross multiply 6x equals 42. And we can decide that by dividing by 6, x must be equal to 7. All right, so x must be equal to 7. Another way is, well, you could have thought of similar triangles. So the small triangle at the top, you know, had a side measure of 6 and a side measure of 2. The larger triangle would have to be proportional to that. So it has a side measure of 6 plus 21, which is 27, and a side measure of, well, I don't know. All right, so I could think of it as, well, 6 and 2, what's their relationship? Well, that side is 3 times greater than the other one. So 27 is going to be 3 times greater than this side. In other words, 27 divided by 3, that's 9. This larger side is going to be equal to 9. And if I think that this guy is 2, then that makes, once again, x equal to 7, because 7 plus 2 is 9. All right, so that's two different ways to think about triangle proportionality. Again, these are similar triangles, and we're going to talk more this week about how we can actually prove that the two triangles are similar and what kind of postulates and theorems exist to say that two triangles are similar. For right now, it is enough for me to know that the sides will continue to be proportional.